So now we're going to talk about quadrilateral characteristics. So the first thing we want to make sure we're clear on is what the nature of the sides are and how they're named. The sides are formed by line segments where adjacent vertices then form the sides. This is redundant, but it's important to kind of think of it both ways. Here's why. When you have a quadrilateral, typically when we're naming a quadrilateral, we'll use whatever the name of the quadrilateral is, like parallelogram, or we don't know, just quadrilateral. And then we'll list off the vertices in order. So for instance, this could be quadrilateral A, B, C, D, or just as easily it could be B, C, D, A, as long as you have it in order by the sides. This way we know that if we were to connect A and B, that would be forming a side. This is important when we get to diagonals. Diagonals are formed by connecting non-adjacent vertices in a polygon. Now, I say polygon because it works for any size, many-sided figures, but in particular, when we talk about quadrilaterals, for instance, if AB is a side and BC is a side, then we know that if we were to connect B to D, let's try that again, BD is a diagonal. Now, if you look at this, we would say that A and B are adjacent vertices because they're next to each other and they form a side. B and C are adjacent, right? So adjacent. And then we'd say that BD are non-adjacent, that is not next to each other. We'd also could say that if we're looking at angle B, and this is where we get to the next part, when we look at angle B and angle D, we would say that angle B and angle D are opposite each other. Now, this only really works for quadrilaterals because they have four sides, so it's easy to distinguish. There's only two adjacent. We'll see when we get to many more sides that it's kind of hard to say there's many opposite angles, so we don't say that they're opposite angles at all. The angles in a quadrilateral. Now, if you recognize carefully, we've got not one but two triangles here, and we know that all the angles in each of these triangles add up to 180 degrees. So all the angles here add up to 180 degrees. Now, if you look, angle A and angle C, plus this part, plus this part, plus this part, plus this part, which when you add them all up would be the grand total of 180 plus 180, or 360 degrees, which means that the angles in a quadrilateral, the angles sum to 360 degrees. So it's all the interior angles, angle A plus B plus C plus D. Okay, so this gets us to our first special quadrilateral, which is a kite, and that is formed by two pairs of congruent adjacent sides. That is by definition what a kite is. What this means is, and we use our tick marks, one tick mark to one tick mark, meaning this is congruent to this, and this is then congruent to this. The key thing we want to talk about here, besides the two pairs of congruent adjacent sides, is the fact that when we look at a kite, there are not one but two diagonals. So this diagonal here and this diagonal here. Now, it just so happens another property is that these diagonals form a right angle, and the longer diagonal bisects the shorter diagonal. Now, for convenience sake, I've kind of written this down here, so let me bring that up. Now, it also says that the longer diagonal bisects the opposite angles. So if you're looking at this, you can see that, say this is A, B, C, D, and let's say they cross at point E. If you're looking at this angle here, angle A, B, A, E, it is going to be the same, that is, this diagonal is bisecting it, it's going to be the same or congruent to angle D, A, E. And likewise, now they're not the same, so I'm going to use different tick marks, two arcs to two arcs. The same is true about angle BCE, that is, it is congruent to angle DCE. Trapezoid. A trapezoid, by our definition, is a quadrilateral with exactly one pair of parallel sides. Now, these one pair of parallel sides, remember how we mark parallel is, so if we're looking at this, let's say this is B, E, F, G, but it seems that B, E, and G, F are the parallel sides, we would mark those thus, and these would be the bases. So B, E, and G, F would be the bases, and the other sides would be referred to as legs. This gets a little bit more important when we start talking about isosceles trapezoids. Now, by dint of being parallel, it turns out that when we look at the adjacent angles, that is angle B and angle G in this case, they are not congruent, but angle B and angle G, that is angle B plus angle, not angle B, angle G, equals 180 degrees. So we can say that adjacent angles, there we go, are supplementary in a trapezoid, but only from one base to the other. So G and F we don't know that about, but we do also know that angle E and angle F are also going to be supplementary because the lines are parallel. So to sum up, we've got the non-parallel sides are called the bases, legs, the parallel sides are called the bases, and adjacent angles of the legs are supplementary. And then there's the isosceles trapezoid, which, simply put, is a trapezoid. So it has exactly one pair of parallel sides with congruent legs. The reason it gets its name isosceles is it's kind of similar to an isosceles triangle, means that this leg is congruent to this. Now it turns out congruently enough that it also means the base angles. Remember, base angles in an isosceles trapezoid, those are congruent. Turns out they are also congruent, that is, the angles opposite in a trapezoid. Now because both of these have to add 180, it also turns out that these angles are congruent. This to this, so if this was A, B, C, D, we know that angle A would be congruent to angle D, and B would be congruent to C. So, key things, legs are congruent, what we call the base angles are also congruent. Then it gets us to a big money maker, the parallelogram. The reason I say that is because it has a bunch of characteristics, but it is the basis for a lot of the other special shapes we know. So, two pairs of parallel opposite sides. Now, it turns out not only is that true, meaning if we're looking at this, and obviously you can't have lines that touch each other being parallel, so we could say that this side is parallel to this side, and this side is parallel to this side. Now notice what I'm doing here, I'm using two arrows, one arrow. I know they're parallel. Now it also turns out that the opposite sides are indeed congruent too. If you think about it, the distance between two parallel lines at the same angle should be the same. And also the opposite angles are indeed congruent. So that means that this angle and this angle as well as this angle and this angle are congruent. And on top of that, the adjacent angles, these two adjacent angles, just like in a trapezoid, because they're opposite parallel lines, the adjacent angles are also supplementary. So to sum up, let's take a look. There's something else I did not mention. Kind of clean this up. So diagonals bisect each other. So looking at this same shape, the diagonals, that is if you're looking at the diagonals, because the lengths between them has to be the same, right? What they do is they do cut each other in half. Just like that. So we know that this is cutting these cutting each other in half. Opposite angles congruent, adjacent angles supplementary, and also the opposite sides are congruent. Then a rhombus. Now, as we get more specialized, turns out we have fewer special features. So it's a quadrilateral with 4 congruent sides. Now, because of that, it also ends up being a parallelogram, which means it gets all the properties of a parallelogram. But it also gets perpendicular diagonals that also happen to bisect each other. Now, it gets to bisect each other from the fact that it's a parallelogram, but it also means, and this is similar to what a kite does, it does mean that the opposite angles are bisected by the diagonals. Now, if you look carefully, you can see 1, 2, 3, 4 congruent, and also right triangles there too. So there's a lot of stuff going on with the rhombus, but if you think of it as a parallelogram, then you know that it has all those properties plus the 4 congruent sides, and then it gets all these bonus features from the diagonals. But they are similar to a kite. If you look at it, it kind of makes a little bit of sense based on the shape. Getting closer to the end here, and we are now at rectangle, which is a, strictly speaking, select that, a parallelogram with 4 congruent angles. Another way to look at that is it could be thought of as a quadrilateral. It could also be thought of as a quadrilateral with 4 congruent angles. Now, because it does have the 4 congruent angles, it does also make it a parallelogram, which is why we also see that definition. So you can show something's a parallelogram and show it has 1 congruent angle, as it turns out, you're good. All the things that you know about rectangles, because you've probably seen quite a bit, are true. Opposite sides are congruent, opposite angles are congruent, but also adjacent angles, because all the angles are congruent. Opposite sides are parallel. And as an added bonus, the diagonals, it turns out, they bisect each other because it is also a parallelogram. If you think about it, it has opposite sides parallel, and they do bisect each other, but the diagonals are also congruent. Okay? So, all told, the only really special additional things is that all the angles are congruent. So this is just like a parallelogram, except all the angles are congruent. They're right angles. 90 plus 90 plus 90 plus 90 is 360. And the diagonals are congruent too. Which leads us then to a square, which is, simply put, a quadrilateral with 4 congruent sides, like a rhombus, and 4 congruent angles, like a rectangle. Now, it turns out squares are the most specialized, I'm not going to use the word special, but they are the most specialized shape we've gotten in terms of quadrilaterals, because they have all this stuff going on with the angles and the sides and the diagonals. Because it's a rectangle, the diagonals are congruent. Because it's also a rhombus, because the sides are congruent, the diagonals are also perpendicular, everything bisects itself. It's all sorts of fun stuff going on. As a matter of fact, something to hang on to is that means that all 4 of the triangles formed by diagonals are have a 45-degree, two 45-degree angles, and a right angle, which means they're also isosceles on top of everything else. But we don't say that there's anything special going on with these because they just have all the different pieces of everything that came before. So here's what I'm talking about there. If you look at this kind of flow chart, we have at the very top something I have not mentioned, which is a polygon. I'm sorry, that should not say polygon, I should say quadrilateral. On the fly fixing here. Quadrilateral, and of all these quadrilaterals, there are several different types. So we talked about a kite, which is a type of quadrilateral, and then we talked about, and I'm putting these in certain spots for a reason, a trapezoid, which is another but unrelated quadrilateral, leads to a kite. And then there's the isosceles trapezoid, which goes below it because it is indeed related, which means that everything that's true about a trapezoid is also true about an isosceles trapezoid. That's why the arrows fall, okay? Which means then the other thing that's unrelated to kite or trapezoid, notice how they do not directly connect, is a parallelogram. And then right below parallelogram is rectangle and rhombus, and usually we put rhombus here, and then of all of those, because really a square is a rectangle and a rhombus together, we put square down below. Now, if you want to think about it, there is kind of a dashed line. They're not exactly related, but they're kind of similar in terms of some of their properties. If you think about the diagonals being perpendicular, kites are related to rhombi, which is kind of why it's preferential to put in there. But that line isn't necessarily really there. So that was the crash course in quadrilateral properties, as well as this flowchart, which can be handy for helping remember what the properties are. So if you know what the properties of parallelogram are, then you know that those also apply to rectangle, rhombus, and square, which means less to try to remember. Thanks.